Hello student, I am Arnav Das. Today we discuss about the LC type of oscillator, and that one basically two types. One is the Hartley oscillator and second one is the Colpitt oscillator. Initially we talk about the Hartley oscillator. Basically Hartley oscillator or Colpitt type of oscillator are used for local oscillator in a radio receiver. The circuit arrangement is look like this one, where a voltage divider circuit is used for the transistor one, and they are assembled with the inductor and capacitor in this position as such. The portion which is highlighted on here, it is used the voltage divider 1, where R1, R2 and RE are used for the biasing one, and the RC is converted into the form of the RFC, that is the radio frequency choke. Inductor, that is the RFC in here, if it is work for the DC condition, that is the biasing point of view, if we talk, that time the impedance will be 0. Ideally it will be 0, or it is so less impedance value will be come on there. That means it will be work just like as a short circuit one. But if we consider for the AC one, that time RFC, this one will be work as a high impedance value, because we know that XL is equal to 2 pi of FL. So if the impedance value is increased, that time the RFC work just like as a high impedance value form or open circuit, and if XL is as a decreasing form or low value, that time it will work as a short circuit, and that one will be effect due to the reason of frequency which one you are choosing on there. If we consider the CB, CC and CE, this is used for bypass the AC component. CE is used for DC biasing condition. If there any leakage AC signal is come on here, that time it will be bypassed to the ground position. And CB and CC is used for the bypass of AC signal, and which is required for amplifier one also. The equivalent circuit, if we consider for the voltage divider 1, that time there this section, that is the this section is extra added would be XL is connected with the base terminal via the CB. So this is the input side impedance or input side inductance will be defined by the L1, and L2 is connect with the CC or via CC to the collector side. That means it is indicate for the output side impedance 1 for the inductor 1. And capacitor C is the varying form which is used for varying the oscillating frequency. If we want to change the frequency to generate one point of view, that times capacitance value you can change here to change the oscillation frequency. So we are going to the equivalent circuit diagram for this total configuration one. And for the equivalent circuit diagram, we introduce L1 as a form of Z1 impedance value, and the L2 is replaced as a value of Z2, and C is replaced as a value of Z3, because if we interchange the position as a L as a form of C, that is in this L position, if you change as a form of capacitor, this is form as a capacitor, and this is L2 is another one capacitor, and capacitor in this Hartley type of oscillator, if it is changed into the form of the coil or transformer, that time this same circuit will be changed as a form of the Colpitt type of oscillator. So if we derive a generalized expression, By establishing this L1, L2C as a form of Z1, Z2 and Z3, that time the same circuit can be analyzed for the both type of circuit diagram, that is Hartley type of oscillator and Colpitt type of oscillator. Equivalent circuit diagram is look like this one. This is the equivalent circuit. For the voltage divider biasing, their equivalent circuit position input side R1 and R2 are connected as a form of the parallel. If we recall our memory, that time R1 and R2 was present in this position. But in this position, for our simplicity, we just remove this two resistance value, because R1, R2 for the circuit designing time you have to choose in such a way the parallel impedance value will be so high on there. So this section can be omitted for the analysis easy point of view. And there a induced voltage source is present, and that one is the H of Re into of V of 0. This is also is omitted on here, or this is shorted, because H of Re for this kind of circuit diagram we have to choose in such a way this is so less. So if it is so less value, that time H of Re into V0, this value also will be so minimal one. So that time it can be considered just like as a short circuit, and for this reason this is short circuited one, and at the input side only the HYE, that is the input impedance, is applied on there. For the output side, there H of, if you just recall the output side, that H of OE and R of C and the R of L is present on there. So for the H of OE, you have to choose so small value. If H of OE is so small value, that time admittance value of 1 by of H OE, which was present for this case, this will call, or this will also happen as a form of open circuit due to the high impedance value. And for this reason, this is omitted in here also for simplify our topic. And RFC is connected in this position. That one also omitted in here. Why? Because for the AC signal condition, we know that XL is equal to 2 pi of FC. This is, sorry, 2 pi of FL. So if F is the high one value, that time the XL value will be the high. So it will be work just like as a open circuit form. And ultimate, due to this assumption, the ultimate equivalent circuit for the voltage divider is look like this one. And there the L1, which is replaced as the form of the Z1, one terminal is connected with the ground. Look that there the one terminal is connected with the ground, another terminal was connected via the CB with the base terminal. So this is connected in this position. And the L2 position, which is written in here as Z2, there one terminal is connected with the ground and another terminal is connected via CC transistor with the collector side. So this is also connected as such. And the capacitor, which is replaces in here as a Z3, the two terminal is connected to one L2 one side and another one is connected with the L1 another side. So this is the total equivalent circuit for the hybrid, or sorry, equivalent circuit for the Hartley and also the Colpitt one. So if you are interested to identify the value of the frequency which is generated on there, that time initially you have to fulfill the criteria, that is the Barkhausen, which is indicate that their A into of beta, that is the mod value, should be equal to 1. A is the voltage gain forward and beta is the feedback gain. So if this product value is the 1, that time this kind of circuit can be oscillate one. That means the positive feedback should be applied on there. So you have to identify what will be the value of the voltage at the output side, what is the voltage at the input side and ratio between them to get the value of A, and same way what portion of the voltage is come as the input side as a feedback one, and on that point of view we can calculate the value of beta also. So for this reason initially we have to take the value for the output impedance one, because if we identify the output impedance, then output impedance, if we multiply with the current, that time the total voltage drop will be come out on there. So what will be this one? This will be as a value of, this will be as a value of, this is H of Fe into of Ib into of ZL. If we consider the output impedance is the ZL, that time V0 can be write down as a form of H of Fe Ib into of ZL. Look, that direction for the current is downward, so here sign will be as a -1 there. So V0 output voltage will be defined as a minus of H of Fe Ib into of ZL. And if we consider for the input voltage, that is the V of in, that will be defined as a input resistance value is the impedance value is also H of I into of input current is defined the I of V. So it can be write down V in is equal to H of I into of IB, and output voltage as we say this is H of Fe IB into of ZL. So we have to calculate the value of output impedance. How can we got this one? This will be got it by identifying the what is the resistance value between these two nodes, that is the node number 2 and node number 3. So between these two nodes their two impedance is connected as a parallel form. One is the Z2 path and another one is this one path. So these two paths are parallel, and these two path parallel impedance result will be defined as ZL. So it can be written as a form of, as I say, this is Z of L, this is Z of L, can be written down as a form of Z2 parallel with Z3, which is series with two impedance one, that is the Z1 parallel with H of IE. Let Z of 1 parallel of H of IE is defined the Z1 dash. So Z1 dash is series with the Z3. This portion is series with the Z3, and this total path is parallel with the Z2. So this is written as such, and we calculate in here also the impedance value in such a way. Look that here this is written as such. Look that Z1 dash is defined as a value of parallel of H of IE and Z of 1, and the combination of these two paths is Z1 dash plus of Z3. That means we are talking about this section. Here this impedance value is defined as a form of Z1 dash plus of Z3. So their value will become, after getting this formation, this is H of I multiplied with the Z1 plus of Z3 plus of Z1 Z3 divided by Z1 plus of H of I. So this total one is parallel with the Z of 2. If we calculate this one, then we can able to got the value of Z of L. So look that here the process is going on there. So ultimately you get the value for the Z of L. So this is Z of L is written as such. For the voltage gain, A is defined the V0, that is the output voltage by the V in, and we already calculate this one, that is the H of Fe IB into of ZL minus, obviously due to the direction of the current is opposite, and divided by for the V in is as a form of H of IE into of IB. So upper side and the lower side, both sides is the IB is present. So here the IB was, and this the below side also the IB, because input current is IB into of IE. So the IB, if you cancel each other, then the gain, voltage gain without feedback will be defined as such. Okay. Now here we just apply the value of this one. Now we are interested to identify what will be the beta value on there. That is the what fraction value of the voltage is come at the input side. That one will be depend on the path of this one, and that time the value will be this one. Output section, look at circuit diagram. So this is the output side, port number 3 is the output side. So by this path the feedback value or voltage is come at the input side. This is the input side one, this section is the input side one, and emitter and base terminal is the input side. So here impedance value is z of 3 plus of z of 1 parallel with of h of IE multiplied is, this is the impedance value for this path with the current of I of 1, because for this loop the current is defined as a form of I of 1, so it can be write down as such. So ultimately you got the value for the V0, which is feedback one. This is the feedback value. Look that this is written in here. Now you already know the value of Z1 dash, so you just put this one value, and ultimately the expression will become for the feedback voltage will be as a form of this one. So what will be the beta value on there? Beta is the feed input voltage is in here, the feedback V0, and output also will be calculated on here. So feedback input terminal is there, 1 and 2 is given to you. So from there the ultimate expression V of FB will be as a form of this one. This is Z1 dash into of IP. This is the feedback one, and ultimately the value for the beta will be there. The output is coming for that particular section. Output is coming as the V of FB, and input is applying V of 0, which is induced as the input side also connected on there. So V0 section is defined in here. So if you put these two value individually for the position of V of FB and V0, that time expression for the beta will become this one. So now we already know about the value of A, that is the their without feedback voltage gain, and the feedback gain also, that is the beta one on there. And by following the Barkhausen criteria, and which is specifying that A beta should be equal to 1, if you put the value for the A and already you calculate this one, and beta value in this position, so this product value should be equal to 1 on there. This should be equal to the value of 1. If you simplify this one, that time the ultimate expression can be modified, or it can be written as a form of this one. This will be the, and this is so much important expression also. You should be remember this one for your simplicity. And h of I, which is h of IE, which is multiplied with the Z1 plus of Z2 plus of Z3 plus Z1 Z2, which is multiplied with the 1 plus of h of FE plus Z1 Z3, which is should be equal to 0. So if we consider for the Hartley type of oscillator, Z1 is the impedance one value due to the region of the inductor, and there should be a mutual inductance will be present, and this is written as such: Z1 is equal to J of omega L1 plus of J omega M. Mutual inductance value is the M on there. The Z2 is defined as a reason for the inductor L2, and which will be as J of omega L2 plus of mutual inductance value plus of J omega M, and Z3 will be written as a value of 1 by J omega C, and this can be also written as a minus of J by omega C. If we substitute this value with this generalized equation, what is the generalized equation? This one. In this position, if you put the value of z1, z2, this total one, if you put the value of z1, z2, z3, that time this expression can be write down by separating the real part and imaginary part. Look that this portion is created now as the imaginary part, this portion is created as a form of the real part. From the imaginary part you can able to calculate what frequency it can generate, and the imaginary part you can able to identify what kind of condition you should be fulfilled to maintain the oscillation process. So initially we are interested to identify what frequency it can be generated on there. So we take here the imaginary part. So you just take this one section, this one section. So this is omega of h I multiplied with the L1 plus of L2 plus of 2m minus of 1 by omega c should be equal to 0, because at the right hand side imaginary part was missing, so this is equal to 0 on there. And h of IE is the parameter for the transistor, so this value cannot be equal to 0. So then should be, you can write down this section, that is the L1 plus of L2 plus of 2m minus of 1 by omega square c should be equal to 0. And from this expression you can simplify that omega will be as a form of this one, and we know that omega is equal to 2 pi of f. Omega is equal to 2 pi of f. You, if you put this value at the position of the omega, and from this you can get the value for the f also. So in that case the f will become as a form of 1 by 2 pi, from this one section 1 by 2 pi into of 1 by root over of L1 plus of L2 plus of 2m into of C. And as we told you that the imaginary section is identified to identify what kind of frequency it can generate, and the real part you can able to identify what condition should be fulfilled to maintain the oscillation process. So you just take the imaginary real part in here. So if you take the real part for this one, and from where it can be come out, this is the section where we just got it, this one. Look that this is the section, this is the section. Here the frequency should be present, omega should be present on there, L1 should be present on there, so obviously this term cannot be 0. So we can conclude that this one section can be as a value of 0. So if you put this one as value of 0, that time expression is written as such, that is the L2 plus of m multiplied with the 1 plus of h of Fe minus of 1 by of omega square of c. You just put the value for the omega 1 on this position, and if you calculate, then you can got the value of h of Fe. So from the h of Fe, this is identify that h of Fe you should be choose in such a way this will be exact value as a form of the ratio of L1 plus of m by of L2 plus of m. So when you purchase any kind of transistor for generating the LC Hartley type of oscillator or LC type of oscillator designing point of view, that time you should be memorized that the L1 inductor and L2 you have to choose in such a way the ratio between them will be exact value with the h of Fe for maintaining the oscillation 1. The same procedure you should be applied for the Colpitt type of oscillator. You just replace L1 as a form of C1, L2 as a form of C2, and C as a form of Z3 on this position. Look at the circuit diagram, so it will be easy for understand also. Look at the portion, it is same as such for the, this is the DC biasing one, this is the same on there, but only the L1 is replaced, L1 is replaced as a form of the C1, and L2 is replaced as a form of the C2, and C is replaced as a transformer, that is the L on there. So at the uh, generalized expression Z1, you can consider this is the reason for the C1, and at the generalized expression J2 position you just put the value for the C2, and Z3 you just replace for the inductor one. So if you replace this value, that time the this is the generalized expression. This is the already you know that of what is the way by which you got this one. You should be remember this one, because various kind of mathematical problem can be come to you, and if you remember this one, that time this is so easy for calculate that kind of problem on there. So h of I is multiplied with the summation of z1, z2 and z3. So z1 is there is minus of j by of omega c1, z2 is equal to minus of j of omega c2, and z3 is due to the inductor, that is j of omega l. If you put individual value at this generalized expression, in this generalized expression, if you put this value individual on this, that time this expression can be rewrite as the real and imaginary part again. So from the imaginary part you can able to identify what kind of frequency it can generate. This is the imaginary part. You can able to identify what kind of frequency it can generate on there, and from the real part you can able to identify what kind of condition you should be fulfilled by which the oscillation process can be maintained on there. So initially we just check that what kind of frequency it can generate by the Colpitt type of oscillator. So in here, and this is can be write down as such. This is the imaginary part. So this section is equal to 0. That is 1 by omega c1 plus 1 by of omega c2 equal to omega of L. This one. So from there you can write down omega is equal to root over of c1 plus of c2 pi of L into c1 c2. And from this you can get the value of f, because omega is equal to 2 pi of f. So expression will become for the f is as such, that is the 1 by 2 pi, and this is the value of f which is generated by using the Colpitt type of oscillator, that is f is equal to 1 by 2 pi root over of c1 plus of c2 by L into of c1 c2. And from the real part, if you consider this is the real part position, and from there you can calculate that h of fe. When you are interested to design a Colpitt type of oscillator transistor, HFE parameter should be as a equal value of ratio between the C2 and C1. So if you consider FE as such, that time when you design a Colpitt type of oscillator by using the C2 and C1, and that time this oscillation can be maintained on there. So I think each and everyone can able to understand this kind of LC type of oscillator, and basically we are discussing here for the Hartley and Colpitt type of oscillator, and hope each and everyone learn about this in detail. And next day we talk about with the new topic. Till I have to say have a good day and bye.